This is the OCR GCSE 9-1 Maths Paper 6 from the November 2020 series, and this paper is a calculator paper. Question number 1. The travel agent records the duration and cost of the 15 flights he sold on one day. The data for the first 13 flights are plotted on the scatter diagram. We've got the duration in minutes, the cost in pounds. For part A, the data for the final two flights is, for a duration of 210 minutes, the cost is £130. For a duration of 1 hour 40 minutes, the cost is £80. We have to plot these flights on the scatter diagram. 210, 130, well, that will be over here. 1 hour 40 minutes. Well, first of all, the duration is in minutes. So we need to convert this 1 hour 40 minutes to just minutes. 1 hour is 60 minutes. 60 minutes plus 40 minutes is equal to 100 minutes. So 180, that will go over here. Now for part B, the cost of one of the 15 flights has been discounted in a sale. We have to circle the most likely flight on this scatter diagram. We need to circle the outlier. Here is an outlier. It does not follow the general pattern of the rest of the data. For the first part of part C, we have to draw a line of best fit on the scatter diagram. For the line of best fit, we have something looking like this. We have roughly the same amount of points above the line as we do below the line. The next part of part C, we have to use the line of best fit to estimate the duration of a flight costing £90. Well, if the cost is £90, we have to estimate the duration. So 90 is roughly here, and reading down, we've got 110. So we have 110 minutes. Well, 7 hours, which is the same as 420 minutes, is outside the dataset. Question number 2, we have to solve 3x plus 4 being less than 19, showing our solution on a number line. We begin with the 3x plus 4 being less than 19. We begin by subtracting 4 from both sides. That leaves us with 3x being less than 15. We now divide both sides by 3, and if we do that, we are left with x is less than 15 over 3, which is 5. So we have x being less than 5 for our solution. And if we were to represent this on a number line, we want everything going this direction. We put an empty circle in because we've got a strong inequality symbol. Question number 3. The graph shows the cost of electricity with company A. So we've got the cost of electricity and the electricity used in kilowatts. For part A, we have to use the information in the graph to estimate the cost of electricity for a customer who uses 450 kilowatts hours of electricity. Well, for 50 kilowatt hours, we have the cost being £6. So, for 50 kilowatt hours, the cost here is £6, and we want the cost of 450. So we need to multiply by 9, and if we multiply by 9, we get 54. So we have £54. Next, Company B charges 14.3 pence per kilowatt hour of electricity used. If Company B's cost of electricity was plotted on the same axis as Company A's cost of electricity, which line would be steeper? Explain how you know. Well, if I take a look at A, what we can do is find out what 1 kilowatt hour is worth in pounds. So, to do this, I need to divide by 50. And if I divide by 50, let's just show this in a different colour. I need to divide by 50 and divide by 50 over here. So 6 divided by 50 is 0.12, which is the same as 12 pence. So if I take a look at A, 1 kilowatt hour is worth 12 pence, and this is less than the 14.3 pence, which was for Company B. So Company B would have a steeper line because 12 pence per kilowatt hour for A is less than the 14.3 pence per kilowatt hour for B. Question number 4. Nina estimates the value of the square root of 3.93 times 393 over 0.546 times 220 all to the power of 3 by rounding each number to one significant figure. Show that Nina's answer is 64. Well, if I work out the value of this by estimating, the 3.93 to one significant figure is 4. The 393 to one significant figure is 400. To one significant figure, we've got 0.5, which is the 0.546 rounded to one significant figure, and then the 220 to one significant figure is 200. And then we need to cube this and then square root. And if I work out what this is, we have 4 times 400 divided by 100, which is 16. So we've got 16 cubed, which is then square rooted, and if I work out what this is, 16 cubed square rooted is 64. And that's exactly what we wanted to show. Now for part B, we have to calculate the error in her estimated answer as a percentage of the exact answer. If I work out the exact answer, I've got the square root of 3.93 times 393 over 0.546 times 220 cubed. So the exact answer is 46.10570486. So for the percentage error, we have 64 subtract 46.1 etc. divided by the 46.1 etc. multiplied by 100. So I've got 64 minus this divided by this multiplied by 100. So it turns out we get 38.81 etc. percent. So to one decimal place, we've got 38.8. This is to one decimal place. Question number 5. For part A, we have to work out the size of the exterior angle of a regular 12-sided polygon. The exterior angle is equal to 360 divided by the number of sides n. So we've got 360 divided by 12, which is equal to 30. So we've got 30 degrees for the exterior angle. Part B, we have to use our answer to part A to write down the size of the interior angle of a regular 12-sided polygon. The interior angle is equal to 180 minus the exterior angle. 180 subtract 30 is 150. So we've got 150. Question number 6. A truck is used to transport some wood panels. Each wood panel is a cuboid measuring 2.4 meters by 1.2 meters by 1.8 centimeters. The density of each wood panel is 750 kilograms per meters cubed. The truck can carry 15 tons of these wood panels. We have to calculate the maximum number of wood panels that the truck can carry. Show how you decide. First of all, you'll notice here we've got centimeters. Centimeters to meters, we have to divide by 100. Meters to centimeters, we have to multiply by 100. And so 1.8 centimeters is the same as 0.018 meters. We also have information about 15 tons, and if we take a look at the units here, we've got kilograms. We know in 1 ton there are 1000 kilograms, and so therefore for 15 tons we've got 15,000 kilograms. Let's first of all calculate the volume. The volume is equal to 2.4 meters multiplied by 1.2 meters multiplied by the 0.018 meters. And if we work out what this is, we end up with 0.05184 meters cubed. And so therefore, for the mass, that's equal to 750 kilograms per meters cubed, which is the density, multiplied by 0.05184 meters cubed. And it turns out we get 38.88 meters cubed, rather kilograms. And so therefore, the maximum number of wood panels, we've got 15,000 divided by 38.88, and if I work out what this is, we get 385.8, etc. So the maximum number of wood panels we can have is 385. Question number 21. Vectors A and 4B are drawn on the grid. That's what we see here. We have to write for part A, vector A as a column vector. Well, you can see we go four across, and then we go 2 down. So A is equivalent to 4 minus 2. For part B, we have to find vector B as a column vector. Well, we know what 4B is. The vector 4B is equal to, if I go back here, we go 4 across and 9 up. So the vector 4B is equal to 4, 9, and therefore the vector B is equal to 1/4 4, 9, which is equal to 1, and then we've got 9/4. So I've got 1 and 9/4. Question number 8. Lee has tea toy bricks. She only has red bricks and blue bricks. Lee picks 2 bricks, one after the other. If the first brick she picks is red, the probability that the second brick is red is 2/3. If the first brick she picks is blue, the probability that the second brick is red is 7/10. We have to calculate the value of t. If we let r equal the number of red bricks, then we have r minus 1 because we've already chosen a red brick, and choosing another red brick means there's r minus 1 red bricks left over out of t minus 1. And this is equal to 2/3. And if I rearrange, I've got 3 lots of r minus 1 equals 2 lots of t minus 1. And if I rearrange this equation, I've got 3r minus 2t equals, well, here I'd have minus 2 plus 3, which is 1. And I can also see that if my first pick is blue, then probability that my second brick is red is 7 out of 10. So similar to before, I've got t minus 1. And then r on the top. So this is the probability that the second brick is red. And this is equal to 7 over 10. Now, what we aim to do is find out what t is. So we need to somehow find out what t is. We can do this using algebra. So we've got two equations here, and we need to solve them simultaneously. So how could we go about this? Well, from here, I can see that t minus 1 is equal to r minus 1 divided by 2/3. And from here, I can see that t minus 1 is equal to r divided by 7/10. Now, if I set these two equal to each other, I've got r minus 1 over 2/3, so that's the same as 3 lots of r minus 1 over 2. This will equal 10r over 7. I'm setting these two equal to each other because they're both equal t minus 1. And if I find out what r is, I can then find out what t is. So if I solve this, well, if I cross multiply and multiply both sides by 14, then this and this cancel 7 times, and this cancel twice. So I've got 7 times by 3, which is 21. So I've got 21 lots of r minus 1 equals 2 times by 10, which is 20, and then I've got r. So I've got r equals 21 from here. And knowing that r equals 21, t minus 1 is equal to 21 divided by 7/10. So 21 divided by 0.7 is 30. So therefore, t is equal to 31. So I've got 31. Question number 9. X is directly proportional to y, and y is directly proportional to z. When x is 10, y is 60. When y is 8, z is 1.6. We have to find a formula for z in terms of x. Well, if x is proportional to y, we can say from here, x is equal to a multiplied by y. Now, we know that when x is 10, y is 60, so we've got 10 equals a multiplied by 60, and therefore a is equal to 1/6. From this we can see x is equal to 1/6 y. And therefore y is equal to 6x. We also know y is directly proportional to z, so we've got y equals b times by z. We know that when y is 8, then z is 1.6, so I've got 8 equals b times by 1.6. So if I find out what b is, 8 divided by 1.6 is 5. And so therefore, I can see y is equal to 5z. And recognizing that y is equal to 6x and y is equal to 5z, we can set these two equal to each other. So I've got 6x equals 5z because they both equal y. We have to write a formula for z in terms of x. So we need a z equals. So z equals 6 over 5x. So I've got z equals 6x over 5. Question number 10. Paintings are sold in an art gallery. The cost of a painting has K% commission added to it. The tax of 15% is then added to the total cost to give the price to pay. Layla correctly calculates the price to pay by multiplying the cost of the painting by 1.403. We have to work out the value of K. Well, we've got our final multiplier being 1.403. So we have 1 plus K over 100 multiplied by 1.15. That's equal to 1.403. We've got the commission and we've also got the tax. So we need to find out what K is. So 1 plus K over 100, that's equal to, well, I've got 1.403 divided by 1.15, which is 1.22. K over 100 is equal to this amount minus 1, which is 0.22, and therefore K is equal to 0.22 multiplied by 100, which is 22. And so therefore K is equal to 22. Question number 11. Here are two function machines. Function A, we've got an input, we times 3, we add 15, we get an output. Function B, we've got an input, we add 11, we times 2, we get an output. For part A, for the first part, Jo chooses a number x. She inputs x into each function. The two outputs are equal. We have to work out the value of x. If the two outputs are equal, well, here, if I consider A, my output is equal to, well, I take my input, I times it by 3, and then I add 15 to it. If I take a look at my function B, my output, I take my input, I add 11 to it, and this is then multiplied by 2. And the reason it's multiplied by 2 is because I multiply it by 2 here. What we know is that the two outputs are equal, so I've got 3x plus 15 equals 2 lots of x plus 11. 3x plus 15 equals 2x plus 22. So I've got 1x, which is equal to 7. So that the input is 7. And next we have to explain why there is no other output that gives two inputs that are equal. Quite simply, the equation we described has exactly one solution. Now for part B, here is function C. With function C, we've got an input, we add P, we times Q, we get an output. Kai chooses values for P and Q so that if he inputs any number into both function A and function C, he will always get two outputs that are equal. We have to find the value of P and the value of Q. Well, if over here we let the input equal X, then with A, we already saw what that function machine gave. The output was equal to 3x plus 15. So with function A, we have an output of 3x plus 15. With function C, our output, well, we input x, we add p to it, we multiply this by q. This is our output when we input x. Now, we know that these two are equal, so we've got 3x plus 15 equaling q lots of x plus p. So I've got 3x plus 15 equals qx plus q plus pq. Now if I compare coefficients by taking a look at the x's, I've got 3x which is equivalent to qx, so 3x equivalent to qx, so I've got 3 which equals q. And if I take a look at the numbers, I've got 15 which is the same as pq. So 15 equals pq, knowing that q is 3, I've got 15 equals p multiplied by 3, so p is therefore equal to 5. And so I've got 3 and 5. Rather, that's the other way around. I've got 5 and 3. Question number 12. Students are asked to choose one subject from option A and one subject from option B. If a student chooses their subjects at random, what's the probability that both subjects have the same first letter? Well, how many combinations are there? I've got E which can be matched with either of these, so there's 1, 2, 3, 4, 5, 6, 7. Then I've got this, geography with either of these, so that's 14. And then history with either of these, so that takes us up to 21, and media studies with either of these. What you can see is there are 4 times by 7, which is 28 possible combinations. And if that's the case, then I've got 4. Well, how many options are there with the same first letter? I could have E, so that's 1. I could have also geography with geography. History can't be matched up with anything, but geography could also be matched up with graphics, so there's 3 options. And then media studies, that can be matched up with the music. So there's 4 possible combinations out of 28, which simplifies to 1/7. So the probability is equal to 1/7, or this as a decimal. So we've got 1/7. Question number 13. In the diagram, AED and ABC are straight lines and BE is parallel to CD. The ratio of the length AB to the length BC is 2 to 3. The area of the triangle ABE has an area of 8 centimeters squared. We have to work out the area of the triangle ACD. Now for this we need to recognize that these shapes are similar. From here we can see that AB is 2/5, and the reason I say 5 is because 2 plus 3 gives 5 parts. So AB is 2/5 of BC. Rather, is 2/5 of AC. And if that's the case, then the length scale factor is equal to 5/2. And therefore the area scale factor is length scale factor squared. So I've got 5/2 squared, which gives 25/4. And so the area of the triangle ACD, I've got 8 multiplied by 25/4. 2 times by 25 is 50. So the area is 50 centimeters squared. Question number 14. The base of the cone is fixed to the top of a cylinder to make a decoration. That's what we see here. The radius of the base of the cone and of the cylinder is r centimeters. The cone's height is 5r centimeters. The total height of the decoration is 6r centimeters. The total volume of the decoration is 225 centimeters cubed. We have to calculate the value of r showing our working. We know the volume is equal to 1/3 pi r squared h. So, to find out the volume, we've got 1/3 times by pi times by radius squared times by 5r. The height of the cone is 5r. And then we've got the area of the cylinder. So here we've got pi multiplied by radius squared multiplied by its height, which is r. And the reason its height is r, 6r take away 5r is just r. So the height over here is quite simply r. And we know that the total volume is equal to 225 centimeters cubed. So I've got over here 5/3 pi plus 1 pi, which is 8 pi over 3. So I've got 8 pi r cubed divided by 3 equals 225 times by, 225 divided by this. So I've got, and then if I divide this by pi, I've got r cubed, which is equal to 26.85. So r is equal to cube root of this, which is 2.9947. So I've got 2.99 to 3 significant figures. Question number 15. A bus company has a large number of buses. 25% of the buses are more than 10 years old. If a bus is more than 10 years old, the probability that it will start first time is 0.3. If a bus is less than 10 years old, the probability that it will start first time is 0.65. Amir is asked to drive one of the company's buses chosen at random. we have to calculate the probability that the bus starts first time. Well, to do this question, one way we can do this is to draw a tree diagram. Here is our tree diagram. Got buses being more than 10 years old, less than 10 years old, and them starting or not starting. Now, if it's more than 10 years old, the probability that it will start the first time is 0.3. So more than 10 here, well, 25% of the buses are more than 10 years old. So here I've got 0.25. So here I've got 0.25. And then less than 10 years old, I've got 0.75. Now, if it's more than 10 years old, probability that it starts is 0.3. So probability that it won't start is 0.7. Now, if it's less than 10 years old, the probability that it starts is 0.65. So probability that it won't start is 0.35. We're looking at the probability that the bus starts for the first time. So I need more than 10 years old and starts, or we could have less than 10 years and then starts. So the probability that the bus starts for the first time, we've got 0.25 times 0.3 plus 0.75 times 0.65. This is the probability that the bus starts for the first time. So if I calculate this, we get 9/16, which is 0.5625. So I've got 0.5625. Question number 16. The diagram shows a circle with center O. The points A, B and C lie on the circumference of the circle. The line AOB is the diameter. The line DAE is a tangent to the circle. And the angle CAE is 32 degrees. For part A, we have to give a reason why the angle ACB is a right angle. Quite simply, the angle at the circumference in a semicircle is 90 degrees. Now, the radius of the circle is 8 centimeters, and with this, we have to calculate the length of BC. So we need to calculate this length over here. Well, we know that ACB is a right angle, so we've got a right angle here, and then we've got the radius of the circle being 8 centimeters, so we've got 8 over here and 8 over here. We want to calculate what BC is. Now, we also know what the angle here is. We've got the tangent and the radius, which are perpendicular to each other. 90 minus 32 is 58. So the angle here is 58 degrees. So now we can create a diagram to illustrate all this. We've got a right angle triangle. Perhaps if I show you the orientation of it, if I rotate this and then enlarge, hopefully here you can see roughly that we've got the same triangle. It's still a right angle triangle. So we've got ABC. So here we've got A, B and C. We know here we've got 58. We know here we've got a right angle. 8 plus 8 is 16. We've got 16 here because we've got 2 radii. And therefore, for BC, we've got the opposite, the hypotenuse given. So BC will equal 16 sine 58. So here we've got 16 sine 58. And if I work out what that is, we get 13.56, etc. So we've got 13.6 centimeters given to three significant figures. Question number 17. Here is a sequence. We've got 3 root 5, 15, and 15 root 5. We have to work out the next term. Well, you'll notice to go from one term to the next, I multiply by root 5. So I'm multiplying by root 5. So to work out the next term, again, I need to multiply by root 5, 15 root 5 times root 5 is 75. So my next term is 75. The nth term then, for part B, I've got a geometric series. My first term is A. My common ratio is, well, let's just highlight this. My first term is A. My common ratio is root 5. And then I'm going to raise this to the power of n minus 1. So my nth term is 3 times by root 5 to the power of n minus 1. Question number 18. We have to write 0.416 recurring, where the 1 and the 6 are repeating themselves. As a fraction in its simplest form, you must show full working to support your answer. Well, what we will do is we begin by letting x equal 0.416161616, etc. And because we've got two digits repeating, we can say 100x is equal to, well, if I multiply this by 100, I get 41.6 41.6 16 etc. And so therefore, if I subtract these, 99x is equal to, well, here, anything here cancels out. So we are left with 41.6 take away 0.4, which is 41.2. And so therefore, x is equal to 41.2 divided by 99, which is 412 divided by 990, which simplifies to 206 over 495. So we've got 206 divided by 495. Question number 19. The graph of y equals 2x squared plus 3x minus 9 is drawn below. That's what we see here. And for part A, we have to use the graph to solve 2x squared plus 3x minus 9 equals 0. Well, here we need to find out the roots of the equation. You can see those are at -3 and 1.5. So here we've got -3 and 1.5. Now, for part B, the equation 2x squared plus x minus 4 equals 0 can be solved by finding the intersection of the graph of y equals 2x squared plus 3x minus 9 and the line y equals ax plus b. We have to find the values of a and b. So, what we will do here, if we solve these equations simultaneously, we end up with the graph here. So if I set these equal to each other, I've got 2x squared plus 3x minus 9 equals ax plus b. And if I rearrange, I've got 2x squared plus 3 minus a x plus minus 9 minus b equals 0. And if I compare with the original graph, I can see that comparing the x's, I've got 3 minus a of them here, and if I compare the numbers, I've got minus 9 minus b. So here I've got 1x, and here I've got the minus 4, so from this I can find out the values of a and b. So I've got 3 minus a equals 1, so therefore a is equal to, if I work out what a is, that's equal to 2. And if I compare the numbers, I've got minus 9 minus b equals minus 4. So therefore b is equal to minus 5. So I've got 2 and minus 5. And therefore for my line, I've got y equals 2x minus 5. And now I have to use the graph to solve the equation 2x squared plus x minus 4 equals 0. So I need to draw the line 2x minus 5. So if I draw the line 2x minus 5, minus 5 is over here and we've got a gradient of 2. So for every 1 we go across, we go 2 up. So here is the graph I need to solve. So stretching it this way as well, we end up with the graph shown here. So, having drawn that graph, I can see I've got an intersection point which goes over here at minus 1.7, and I've also got another one over here which is at 1.2. So I've got 1.2 and minus 1.7 as my intersection points. Question number 20. The vector m, which is equal to 2k, and the vector n, which is given by 3, 11, are shown here, and we've got the vector 2m plus n, which is parallel to 1 minus 1. We have to find the value of k. So if I work out 2m plus n, I get two lots of 2k plus 3, 11. So working this out, 4 plus 3 is 7, 2k plus 11 goes at the bottom. And with that, what we can now do is recognize that this vector here is parallel to this. So how could we go about this? Well, if I take out a 1/7, I'd end up with 1 and 7 lots of 2k plus 11. Well, does this make sense? Well, the ones match up, but here I need a -1, so here I need a minus over here. So, if we think about it, there is a factor of 7 by which these factors are parallel. They're just different magnitudes by 7. So I've got 2k plus 11 equals -7, from which I can conclude k is -9. So I get k equals -9. Question number 21. We have to write as a single fraction in its simplest form x over x plus 2 plus x plus 1 over x minus 2 minus 6x over x squared minus 4. Well, here I can combine these fractions. We've got, if I write this as x plus 2 lots of x minus 2, then on the top what I need is an x lots of an x minus 2. Those cancel out. And then I've also got, well, if I have an x plus 2, x minus 2, then on the top I need, well, the x plus 1 isn't going anywhere, and here I need an x plus 2. It's as though these cancel out, leaving us with x plus 1 over x minus 2. And then I subtract (6x) over x minus 4. So what is all this the same as? Well, on the bottom I've got x squared minus 4, a difference of 2 squares. And on the top I've got x lots of x minus 2 being added to, well, here I've got x squared minus 4, and here I've got x plus 1 lots of x plus 2. And then I subtract 6x over x squared minus 4. So now I can combine all these, so I've got x lots of x minus 2 plus x plus 1 lots of x plus 2 minus 6x, and on the bottom I've got x squared minus 4. So on the top I've got x squared minus 2x. Now here I've got x squared, and then here I've got 2x plus a single x, which is 3x. Then I've got the plus 2, and then I've got the minus 6. And on the bottom I've got the x squared minus 4, which I'm going to rewrite as x plus 2 lots of x minus 2. So if I continue simplifying all this, how many do I have on the top? Well, I've got here a 2x squared minus 5x plus 2, and on the bottom x plus 2 lots of x minus 2. So I need to now factorize this. So for me to factorize, we'll do it at the side. I need two numbers which multiply to give 2 times by 2, which is 4, which add to give the minus 5, So I've got minus 4 and 1. And minus 1 rather. So I have 2x squared minus 4x minus x plus 2. And if I group together the terms, I've got 2x lots of x minus 2 minus 1 lots of x minus 2. So I've got 2x minus 1 lots of x minus 2. Okay. So on the top, I can factorize that as 2x minus 1, x minus 2, and on the bottom, I've got x plus 2, lots of x minus 2. Now, the x minus 2's cancel on the top and bottom, leaving me with 2x minus 1 divided by x plus 2. So I've got 2x minus 1 over x plus 2 as my final answer.